Next, we move to subtopic 10.4, implicit differentiation. The objective of this subtopic is to define the implicit function. Second one, to differentiate implicit function up to second order. What is implicit function? An implicit function is one in which a relationship between, for example, variables x and y is given without having y as an explicit or clearly defined function of x. For example, here y equal to 2x plus 1, y equal to 3x squared minus 7x plus 1, and y equal to x minus 1 over x plus 3 is example of explicit function. However, for implicit function, we can see here the examples are y squared minus 3yx cubed equal to x plus 1, and another one, for example, xy plus 2y equal to x minus 1. How to solve implicit function? How to get the derivative of an implicit function? By using the chain rule. Okay, for example, derivative of function y equal to derivative of d over dx fy equal to d over dy fy times dy over dx. Okay, by using the chain rule. Okay, for example, d over dx y, okay, with respect to y equal to dy over dx. Differentiate y squared with respect to x equal to 2y dy over dx. Because just now we need to multiply with dy over dx. Okay. Differentiate x cubed y with respect to x. This one is u. This one is v. U v prime plus v u prime. Okay. So x cubed dy over dx plus 3x squared times y. So we get this as a final answer. Next, this one, differentiate x cubed over y squared with respect to x. Since it is a quotient, we need to use quotient rule. U and then the denominator is v. V u prime minus u v prime over v square. Okay, v u prime means we need to find the derivative of u. So 3x squared minus this is u. Find the derivative of v. Okay, 2y dy over dx. Okay, for y, 2y dy over dx over v square y power of 4. Okay, and then we solve this one, we can get this as our final answer. Another example, find derivative of x dy over dx with respect to x. Okay, u v prime plus v u prime. Okay, right now u is x. Okay, we get x. Differentiate dy over dx, so we can get this, the second derivative of dy over dx, so d square y over dx square plus v u prime. Differentiate u, okay, equal to 1. Okay, because we differentiate with respect to x, so dx over dx, so equivalent to 1. So we get this as a final answer. Okay, another example, find dy over dx in terms of x and y. If we have a question here, differentiating each term with respect to x. Since here is y, then we need to find with respect to x. So 3y square dy over dx plus differentiate 6x, we get 6, and then differentiate x square, we can get 2x. Okay, 2x. The same thing actually, 2x dx over dx, so equivalent to equal to 1. So but here y, that's why we need to write dy over dx. So to get dy over dx, okay, here left hand side, and then we bring 3y square to the right hand side, so we can get this as a final answer, because we need to find dy over dx. Another example here. Okay, differentiating each term, okay, each term with respect to x. So 3y square is 6y dy over dx. Okay, since it is the variable y, then 2y 2 dy over dx, and then x and y, this is u, this is v. So u v prime, okay, u v prime plus v u prime. U prime x equivalent to dx over dx. So equal times 1 equal to differentiate x cubed with respect to x. So 3x square dx over dx. So no need to write down the dx over dx, because it is equivalent to 1, unless this one with y, variable y, but we differentiate with respect to x, so we need to write dy over dx. Okay, and then we factorize dy over dx like this. Okay, this one we have dy over dx, dy over dx, dy over dx. So yeah, this one we need to bring to right hand side. So we factorize, and then we can solve this one. The value of dy over dx. Okay, next example, the same thing. Because we have two variables here, x and y. So this is u, this is v. Okay, u, v. Alright. So u v prime plus v u prime. Then same thing here, u v prime. Okay, v prime is equal to 1, and then v, because dx over dx, okay, so v prime equal to 1, and then u prime, this one. Okay, u is x square, v prime differentiate y with respect to x, so dy over dx plus v. Okay, v is this one, y. Let's differentiate u. Okay, so we get 2x minus, okay, so this one is u, this one is v prime. Okay, and so 2y cube x, u is 2y cube, differentiate x, okay, dx over dx equal to 1, okay, plus v u prime. Okay, v differentiate 2y cube equal to 6y square dy over dx plus this one differentiate 5x cube with respect to to x. So we get 15x square, and then this one respect to x, so equal to 6. Differentiate 5, the constant, it will be 0. So now you find the dy dx, you factorize. Okay, then another variables that don't have dy over dx, so you need to bring the right hand side. So dy over dx equal to this. And then in the next example, y square x plus exponential 2y x square plus 2y equal to 0. Okay, u v prime, u v, this one u v. because two variables x and y and x here. So u v prime plus v u prime, differentiate y square equivalent to y dy over dx. Okay, uv for exponential to y, uv prime. Okay, this is okay. uv prime is this one, uv prime plus v is x square. Okay, v this one u prime. Okay, u prime differentiate exponential to y with respect to x, so exponential to y, and then differentiate to y, we will get y 2, then dy over dx, plus differentiate to y, so we can get 2 dy over dx equal to 0. So you factorize, okay, the variable which have dy over dx, okay, and then the right hand side without dy over dx, and then we can get this final answer. Right, the second order derivative, we need to find the second order derivative with d square y over dx square for each of the following expression in terms of x, y, and dy over dx. Okay, now we look at example A. X square minus xy plus y square equal to 4. Okay, differentiate this one with respect to x, 2x, and then this two variable, so uv prime, this one. Okay, uv prime plus vu prime. Okay, this one y, so since it is negative, so negative here. Okay, plus y square, so 2y dy over dx, differentiate 4 equal to 0, the constant. And then we need to differentiate once again because we need to find the second order derivative. So differentiate 2x, we'll get 2. Differentiate y dy over dx. Differentiate this one uv. So uv prime. So differentiate dy over dx. So we get the second derivative. Then vu prime. Differentiate this one v dy over dx. Okay. Differentiate u prime equivalent to 1. Then uv prime, okay, plus vu prime, okay, because this one v is dy over dx, and then u prime 2y, so 2y is equal to 2 dy over dx. So since it is double here, so 2 dy over dx square. So we need to factorize, okay, the variables which have second derivative, okay, and then that we have dy over dx to the right hand side, so we get the final answer in form of dy over dx, x and y, dy over dx, x and y. Next example, x square plus xy plus ln y. Differentiate x square to x. This is u, this is v. So u v prime plus v. Okay, u prime is x. So differentiate x equal to 1. Equal to ln y. Okay, differentiate ln y equal to 1 over dy. Dy over d. 1 over y, dy over dx. Differentiate 2x equal to 2. Okay, differentiate y. Okay, the second derivative, dy over dx. Okay, for this one, okay, we get for dy over dx, and then we need to differentiate once again to find the second derivative. So differentiate y, dy over dx, dy over dx. Differentiate x, dy over dx, u v prime. Okay, u v prime plus v, okay, v u prime. Differentiate x equal to 1. Okay, dy over dx times 1 equal to differentiate 1 over y. Okay, we get this, right? Okay, we differentiate this one. This is u, this is v. So u, this one v prime dy over dx. Differentiate once again, so we get second derivative d square y over dx square plus v. Okay, this is v, this is u prime. Differentiate 1 over y. Okay, so 1 over, so it is y power of negative 1. So negative y, negative 1 minus 1. So negative y power of negative 2 equivalent to y, negative 1 over y square. Since it is with respect to x, okay, the variable y, so dy over dx. Okay, we get dy over dx. Then this equivalent to this one. We factorize. Okay, take the value which has the second derivative, bring to the left hand side, and then the dy over dx, another one to the right hand side, so we can get the d square y over dx square. Okay, another example, find the second derivative in terms of x and y. So this one without dy over dx. Just now, for each the following expression in terms of x, y, and dy over dx. Okay, to find second derivative. But for this one, for example, find the second derivative in terms of x and y without dy over dx. Okay, first of all, we need to differentiate x square. So 2x differentiate y square is 2y. dy over dx differentiate 4 equal to 0. And then this one we factorize. Okay, so we get dy over dx equal to negative x over y. And then we need to differentiate once again to get the second order derivative. Okay, so since this is the quotient, we need to quotient using quotient rule. U v u prime minus u v prime over v square. Okay, we get this one. Since this one we have dy over dx, because the question asks only in terms of x and y, so you need to substitute the value of dy over dx, which is negative x over y, into this. Okay, so we get the second derivative negative 4 over y cube. B xy plus y square equal to 3. Okay, this is u, this is v. So u v prime plus v u prime, and then differentiate y square with respect to x, so 2y dy over dx equal to 0. And then dy over dx we factorize. Okay, this one, so we get like this, dy over dx. But we need to find the second order derivative by using the quotient rule. This is u, this is v u prime minus u v prime over v square. Okay, since we have dy over dx here just now, we get dy over dx like this, so we need to substitute. Okay, and then we get this one, right? Then this one we can factorize to xy plus y square. Okay, over x plus 2y cube. Okay, from equation just now, xy plus y square equal to 3. So we can substitute. Okay, 3. So 2 times, so this one is 3. So 2 times 3 over x plus 2y cubed equal to 6 over x plus 2y cubed. Okay, another example. Given y times z 1 plus x square equal to x, prove that this one. Okay, so first of all, we need to find the first derivative and second derivative because we need to prove the second derivative and this one. So first of all, we need to differentiate the left hand side and the right hand side. Okay, we put like this. So find the derivative of the left hand side and right hand side. So this is u, this is v. So u v prime plus v u prime. Okay, differentiate x with respect to x. So dx over dx equal to 1. Okay, u v prime. Since this is the 1 plus x square power of 1 over 2. Okay, bring down 1 over 2. That's why we get 1 over 2 here. And then 1 over 2 minus 1. Okay, 1 over 2 minus 1, we get negative 1 over 2. And then you need to differentiate once again. Okay, inside x square. So x square is 2x. And then v, okay, v differentiate u. So dy over dx equal to 1. So xy. So this one we can cancel out. Okay, so we get xy times 1 plus x square power of half of negative half plus this one. Okay, next substitute the value y equal to this into the equation, because this is power of negative, so equivalent to this one. Okay, over z plus 1 plus z 1 plus x square from equation. Sorry. Okay, we have here y equal to x over 1 plus x square. So that's why here we have like this. Okay, you need to substitute here, so we get y square. Okay, y square plus z 1 plus x square dy over dx equal to 1. Since we need to find the second derivative, we need to differentiate one more time with respect to x. Okay, so differentiate y square, so 2y dy over dx. This is u, this is v, u v prime plus v u prime. Okay, just now like now, go to 0, and then 2y of dy over dx plus this one. Okay, we get, since here okay, power of negative half, so equivalent to like this, right? So this one we can cancel out. So therefore we know that x over z 1 plus x square equal to y. So we can substitute y here, and then we can solve. Okay, this one dy over dx, dy over dx, so 2y plus y equal to 3y, and then this is the final answer. Okay, this one I think you need try to solve by yourself. Okay, for exponential function, this one two different variables, so this is u, this is v. Okay, you need to prove this one. You need to find the first derivative and second order derivative. So you need to solve this one. First of all, differentiate. Okay, and then differentiate exponential x, we get exponential x. This is u, this is v, so u v prime plus v u prime. Okay, v u prime, this one 0, differentiate 4 equal to 0, and then we get this one v u prime dx over dx equal to 1. Then we need to differentiate once again. Okay, differentiate exponential x dapat exponential x, and then this one u, this is v. Okay, so u v prime plus v u prime x. Okay, differentiate x equal to 1, and then differentiate exponential y. So exponential y dy over dx. This one differentiate exponential x, we get exponential x since it is y. Okay, so dy over dx. This one actually dx over dx, but equivalent to 1. So you need to solve. Okay, so we get the second order derivative from this one, all the variables. Okay, we divide by x, all the terms we divide by exponential y, so get this one, right? You can prove this one. This is the final answer. That's all for this chapter. Thank you.